In this lecture, we would be discussing the battery technology for electric vehicles. The heart of any vehicle is the power source. In the case of fossil fuel engines, it is the internal combustion engine. In case of electric vehicles, it is the battery technology. For an electric vehicle, the rechargeable battery technology has increased the viability and popularity of electric vehicles. So if you ask me to list the most important development or the reason why electric vehicles has took off, the reason is the battery technology. So in this lecture, we would be discussing the battery technology. For an electric vehicle, the batteries used are quite different from the batteries which are used in, say, laptops or cell phones or in other consumer electronic devices. The batteries used in vehicles are different because they are required to handle the high power capacity and high energy capacity within a limited space and limited weight. So, high specific energy is required from a source so as to provide long driving range, whereas high specific power is required to increase the acceleration. In other words, we need to choose a battery with high specific energy, providing a long range and high specific power to increase the acceleration. Higher is the energy density, the more energy can be stored in it and released from it. The unit of energy density is watt hour per kilogram, and it is calculated from the electrical power output and the weight of the battery. The range of an electric vehicle is determined from this energy density. We would be discussing the characteristics of the battery in more detail in some other lecture. Just to list the characteristics, let me simply say that the batteries should be fast charging, they should have a long service life, they should have a long cycle life, they should cost less, and they should be maintenance free. Which are the batteries which are available? So the most oldest and popular battery is the lead acid battery. Lead acid battery was invented in 1859 by the French physicist Planck, and it is the oldest type of rechargeable battery. You are quite familiar with this battery because every vehicle, the internal combustion engine vehicle, has got this battery, and this battery provides the current to the automobile starter motors. This traditional 12-volt battery has plates which are made from lead and lead oxide. So you see that in the figure, the cathode, which is a negative electrode, is made up of lead, and the anode, which is a positive electrode, is made up of lead oxide. The electrolyte solution is the sulfuric acid as seen in this figure. We are all familiar with the working of a battery, so I would not be explaining that. Just to list two main types of lead acid batteries, as I said, one is the automobile engine starter batteries and other is the deep cycle battery. Automobile alternators would be designed to provide starter batteries having high charge rates for fast charges, while deep cycle batteries, which are used for electric vehicles like golf cars, and they are also used in auxiliary house batteries. So the lead acid battery has a very low energy to weight ratio. It is that which is a disadvantage. So it is about 30 to 40 watt hours per kg, and it has got low energy to volume ratio. So this low energy to weight ratio and low energy to volume ratio is the cons, the poor density which I listed in the slide. That is what I mean by poor density. That is, it has got a low energy to weight ratio and low energy to volume ratio. But the advantage which I have listed in the pros is it is very cheap, it's inexpensive as compared to the newer technologies. That is the reason why it is one of the most favored battery by the automakers for starting, lighting, and ignition functions, namely SLI functions. So the vehicles without lead acid batteries would not start. The hybrid electric vehicles use lead acid batteries for starting, lighting, and ignition functions. One can also have an electric vehicle completely on lead acid batteries, but then, as I said, it would have a disadvantage because it would require big space. That is because it has got a low energy intensity. The problem is not only of the space and weight. The problem is also that it has got fewer cycle lives, and if discharged below 50% of the capacity, it shortens the battery life. That is what is called as a high recycling rates. That is that is called as a poor life of that, which is called as a cons, which are listed as a disadvantage of the lead acid battery. The other issue is environmental issue. And what is that? It is the issue of disposal of toxic lead. So the lead is used and it is toxic, and that is going to have adverse environmental impact. The advantage is that because it is quite an old battery, so there is a market which is available for recycling. That is what is meant by high recycling rate, which is listed as an advantage in this. So to sum up, the pros, the advantages are it is cheap, it is easily available, and it is having a high recycling rate. The disadvantage or the cons is having a poor energy density, poor power density, the life is poor, and lead being toxic, it leads to adverse environmental impact. The other type of battery which I would like to discuss is the nickel metal hydride battery. So the nickel metal hydride battery, it's also old battery relatively speaking. It was invented in 1967, and this development of this nickel metal hydride battery was sponsored by two companies, well-known companies. One is the Daimler Benz, and other is the Volkswagen AG. This battery uses a positive electrode and a negative electrode. Obviously, as you see over here, the positive electrode is the nickel electrode. It is an alloy of nickel, titanium, vanadium, and other metals. And the negative electrode is the battery uses nickel hydroxide as a positive electrode, and the alloy of nickel, titanium, vanadium, and other metals are used as a negative electrode. The electrolyte is an alkaline solution. So you see in the figure that the negative hydride electrode is mentioned and positive nickel electrode is mentioned, and the pros and cons are mentioned on the slide, the advantages and disadvantages. What are the advantages? As compared to the lead acid battery, it has got double the energy density. It has got a high energy density, up to 80 watt hour per kg. If you remember the energy to weight ratio and the energy density of lead acid battery, it is about 30 to 40 watt hours per kg. For nickel metal hydride, this figure is up to 80 watt hour per kg. So this is about double the energy density. The other advantage is that it is recyclable and harmless to environment. So they are, relatively speaking, harmless to environment, and they are also recyclable. They also have safety issues associated with them. They are relatively safe to operate at high voltage. Their cycle life is also longer. Their operating range, temperature range is long, and they are resistant to overcharge and discharge. So that is what we say that it is called as high charge and discharge rates. So that is the advantage. What is the disadvantage? The disadvantage is that it has got high self-discharge rate. Okay, and the the operating range is relatively small as compared to the lithium ion battery. Okay, but as compared to a lead acid battery, it is relatively long. The charging time is low. It has got a memory effect, and then it is unsuitable for parallel connections. So these are the cons of the disadvantages of electric use of nickel metal hydride battery in electric vehicles. This memory effect, we will discuss it in a moment later. What are the applications of NIMH batteries? So they were used first in all electric plug-in vehicles such as General Motors. Then they were used in Toyota RAV4 EV. They were used in Honda EV Plus. They were used in Ford Ranger EV and Vectre scooter. The hybrid vehicles such as Toyota Prius, Honda Insight, Ford Escape Hybrid, Chevrolet Malibu Hybrid, and Honda Civic Hybrid also use the nickel metal hydride battery. So this is a very popular battery, as you see. The third and one of the most popular battery I'm going to discuss today is a lithium ion battery, and a similar battery is a lithium polymer battery. Lithium ion and lithium polymer batteries, widely known for their use in laptops and consumer electronics, dominate the most recent group of electric vehicles in development. The traditional lithium ion chemistry involves a lithium cobalt oxide cathode. So the cathode is lithium cobalt oxide and the anode is the graphite anode. The energy yield is impressive, the density is impressive. And how much is that? If you compare it with the lead acid battery, which was about 40, or the NIMH battery, which was about 80, this figure is impressive. It is about 200 plus watt hours per kg. So it is twice that of NIMH, and it has got a very good power density, and also the efficiency is pretty good. It's about 80 to 90% charging and discharging efficiency. So these are the advantages of the lithium ion battery. Because of its high energy density, electric vehicles fitted with lithium ion batteries can travel longer distances. For example, Nissan Leaf fitted with a 40 kilowatt hour lithium ion battery pack can travel up to 400 kilometers. That is the range of that vehicle. So you can imagine. There are disadvantages. What are they? So the downsides of traditional lithium ion batteries include the shorter cycle lives. So it has a very few cycle lives, about few thousands. And there is a significant degradation with age. The cathode is toxic, and also the traditional lithium ion batteries can pose a fire safety risk if punctured or charged improperly. So that is a safety issue. And obviously the lithium which is being used in the lithium ion battery is costly. It is found in very few places around the world. They are still expensive. The prices are falling for sure over the last few years. And obviously with the fall in the prices, only the viability has increased. The lithium ion batteries comprise a family of battery chemistries that employ various combinations of anode and cathode. For example, the technologies which are being used are lithium nickel cobalt aluminum NCA battery, lithium nickel manganese NMC battery, lithium manganese spinel, that is LMO battery, lithium titanate, that is LTO, and lithium iron phosphate, that is LFP battery. The current two major battery technologies used in EVs are nickel metal hydride and lithium ion batteries. So nearly all the hybrid electric vehicles available in market today use nickel metal hydride batteries because of its mature technology. Due to its potential of obtaining high specific energy and energy density, the adoption of LiP-ion batteries is expected to grow quickly in electric vehicles, particularly in plug-in hybrid electric vehicles and battery electric vehicles. So this important things we need to consider while discussing the batteries. There are other battery technologies also like nickel zinc battery and nickel cadmium batteries. For example, the nickel zinc battery is used in electric bicycles, scooters, and lawnmowers. The nickel cadmium battery has lower energy density than nickel metal hydride batteries and lithium ion batteries, and they are also costlier and more toxic than NIMH. So, this is an overview of the battery technology, and I'm sure that we need to focus on the battery technology a bit if you want to understand the electrical vehicles. I'll just list down some of the popular batteries which are used in the models and the specifications. Tesla model, for example, uses the lithium-ion battery whose capacity is 100 kilowatt hours. Mercedes-Benz EQC has a capacity of 80 kilowatt hours. Look at this, the capacity is specified in kilowatt hours and also in voltages. Okay, Mahindra e-Verito model has 72 volt battery, whereas Tata Tigor electric vehicle has 220 volt battery. The capacities are about 20 kilowatt hours. So this we need to understand. Batteries always come with the battery management systems, and it's essential because it protects the cells of the battery from damage. It prolongs the life of the battery. For example, we talked about the concerns with lithium ion battery, that is, safe operating area is restricted by the temperature from minus 20 to 55 degrees centigrade, and the voltages in the range of 2.5 to 4.2 volts. So in order to operate in this band, this temperature band and the voltage band, we need to have an efficient battery management system. So this was all about introduction to the battery technology. We'll stop for now. Thank you.